Open source libraries ZLUDA makes a comeback, now working on multi-GPU compatibility for Workloads. ZLUDA, the famous code porting library, has now seen its revival and is now being developed to support multi-GPU compatibility, especially for Workloads. ZLUDA is now being developed under an anonymous sponsor, likely to take iCompute to a new level. For those unaware, the ZLUDA library made headlines a few months ago, and it was initially designed to support Intel GPUs on NVIDIA's software stack, but eventually, AMD took care of the project and, together with multiple developers, molded it in a way that allowed them to break boundaries and access NVIDIA's CUDA onto their own hardware, which was seen as a massive breakthrough for the open source community. However, AMD decided to scrap the project due to legal concerns, but ZLUDA is back, this time with a bang. A new report by Onyx claims that ZLUDA's original developer, Andrei Yannick, has announced that ZLUDA is back to its development phase under an anonymous sponsor, but there is pretty interesting stuff to come ahead for ZLUDA, which we'll talk about next. It is claimed that ZLUDA is now being tuned to allow multi-GPU support, which means that the library will be compatible with any architecture, whether AMD or NVIDIA. Now, instead of optimizing for professional workloads, ZLUDA will focus on ML workloads. This means that the ZLUDA will now support libraries such as llama.cpp, PTorch, and TensorFlow, and the special focus is reworking NVIDIA code paths to make them compatible with other GPU vendors. The involved developers have already started testing too with AMD's RDNA GPUs, and it is said that ZLUDA will support RDNA 1 Plus architectures along with ROCm 6.1 Plus compute stack support. Hence, for the AMD compute portfolio, ZLUDA will prove to be a game changer. Now, in terms of when the library will appear back in the markets, the developer Yannick claims that it will take around a year before the library comes back in shape. If the project proves to be a success, we might see the exclusivity boundaries present in software stacks break, allowing architectures to leverage each other's capabilities for an optimal end result.